For the second circuit, I can just move over to the side and create my circuit on the same sheet. I'm going to go down to digital and grab under flip-flops and latches folder the D flip-flop NEGSR, the second option. And I'm going to copy it and paste it because I need 2 of these. Again, I'm going to go to digital and grab a digital constant, place one at the top, and I'm going to place one about middle on the left side. Under schematic connectors, I'm going to grab a ground, and then I'm going to go to switches and select SPDT, rotate it twice, and then I want to line it up so that it connects to where the CLK input is. I'm going to adjust this, and I'm going to connect the positive to the top of the switch and the ground or 0 to the bottom of the switch. Now I'm going to take this digital constant at the top, and I'm going to connect it to the set on the first flip-flop, as well as the set on the second flip-flop. Then I'm going to connect the reset on the bottom to the top. So all of these are connected to the digital constant, and the second reset is also going to connect to that one. I'm going to take my switch and make it the input for the clock. And then I'm going to take not Q from the first flip-flop and connect it to the second flip-flop for the clock input. Then again, I'm going to have not Q go back into the flip-flop and connect to D. So I'm going to start at D, and I'm going to connect it to not Q. I'm also going to do that with the second flip-flop. So I'm going to go to D, go around, and connect it to not Q. I'm going to go to Analysis and Annotation and grab a digital probe, copy it, and paste a second one. I'm going to take my second flip-flop, output Q, and connect it to the first probe by pressing J on my keyboard. And then I'm going to take the second flip-flop and connect it to, or take the first flip-flop and connect it to the second probe by clicking J on my keyboard. I'm going to click on this probe and I'm going to rename it A. And I'm going to rename the second probe B. I'm going to click on the first flip-flop and name it FF_B. I'm going to name the second, the second one FF_A. I'm going to change my switch to T2 because I already have a T. Then I'm going to press run the circuit. So you can see that when we start, A and B are both 0. When I flip the switch from down to up, so from negative to positive, B changes to 1. So I have the number 0, 1 in binary. When I switch down, nothing happens. If I switch up again, it's going to start the second cycle. or the first cycle. So when I go to the first cycle, now I have A is 1 and B is 0. And you're going to put that on your activity table. Then I'm going to switch down, switch up. For my second cycle, I get 1, 1. Switch down, switch up. For my third cycle, I get 0, 0. Switch down, switch up. For my next cycle, I get 0, 1. And you'll continue 9 times. You'll press stop, save your work, and then you'll move on to question 3.